Direct variation is a straight line. Y varies directly with x, meaning there's a constant of variation, a constant slope. But if it varies inversely, you do not get a straight line at all. So you got to be able to tell the difference. So direct variation, which you had in the last assignment for review, if you remember, is y equals k times x. That's y equals mx plus b. M is k, so k is your slope. Constant of variation is slope. What's b? 0. So the direct variation was a straight line that always went through the origin. Inverse variation. All caught up? X times y equals k, or y equals k over x. Same thing with direct variation. Y over x equals k. But notice the differences in how they look, and they can be confusing, but you must remember what it is. Direct variation is just y divided by x. If you take all the points in a table and divide y by x and they're all the same, that means you have a direct variation. They're all going to be constant. If you do that with inverse variation, you're not going to have the same number. But if you take your inverse variation numbers and take x times y, take each coordinate, take the y times the x, you'll get the exact same number. Okay? This is technically how we write it. This is how we write direct variation. So if I ask you to put it in the right form, that's how you should write it. Okay? Notice y is by itself in both of those. All right, example 1. Let's get through this. Y equals 4 over x. Is that an example of direct variation or inverse variation, or neither?
Inverse.
Inverse. Okay. Example 2. You doing all right?
Yes.
All right. Y equals 4x. Josh? Direct. Matches that right there. Direct variation. Example 3. How fast we're going? This is great. I can tell you.
I wish.
All right, xy equals 5. Brody? Inverse. And example 4. How do you know?
Because there's a y-intercept.
If you're not sure how to figure this out, get y by itself and see if it looks like it. So I'm going to subtract the 2x and divide by the negative 4. Because it has a y-intercept listed. That's why it's not direct or inverse. So this is neither. Sometimes they call this indirect variation. Everybody calls it inverse variation. Okay? So that's just looking at an equation. You should be able to spot that. Now, from here on out, you should remember this stuff. Like all of you did when you were doing your mixed review and you asked what direct variation was. Example 5. Graph. You love graphing. It's your favorite thing to do in the whole world. Y equals 3 over x. Make an XY chart and graph it. You have 30 seconds. I'll help you. And there's the numbers I want you to use. Your XY chart, you will plug in -10 for x, -3, 0, oops, I'm sorry. -1, 0, 1, 3, and 10.
What?
Oh.
For all of them?
30 seconds. Use that brain. Work faster. Time's up. Keep working, I'll head it down. Yeah.
I use different numbers.
Okay, your graph should be the same.
Okay.
You're not going to use these on every problem.
Oh,
I just picked them on this one, so that we would all use the same one.
I just need to say
That's fine. As long as your graph is correct, I don't care what problem, what number. Alright, so this is -3/10 or -0.3. That's -1, -3. This is undefined. When you have 0 in your denominator, it's undefined. That's 3. That's 1. And that's 0.3. Alright, so how do we graph something that's undefined? Let's at first graph what we do know. -10, we have a -0.3, which is very, very small. Okay? That's -1, -0.3 is about right there. Then we go to -3, we have -1, so it's gone down a little bit. At -1, we have -3. So right here, you see a curve. And then it jumps, at 0 we have something undefined. Means it cannot touch it. This is what we call an asymptote.
Oh, what? Oh, what?
Asymptote.
A toad?
Asymptote.
I just heard toad.
You guys are so mature.
I know what this is gonna do. They're gonna curve into each other.
No, they're not.
They're not gonna touch.
They're totally in a different point.
Alright, so if this is coming in
You know what I mean.
increasing exponentially, but it never touches the asymptote. That's what the left side looks like. And it increases but never touches that line. What is that line? What is the equation of that line that it's approaching? What is the equation that this is approaching? Or coming away from? What is the equation of this line?
Oh, y equals 0.
Y equals 0.
Oh.
So this is also an asymptote.
That's just awkward to say.
I'll be like, hey mom, guess what I learned today? She'll be like, what? I learned what an asymptote was. She'll be like,
Alright, so 1, 3 is a point, 3, 1, and 10.3. So this one
Whoa.
falls away.
See, I told you I knew what it was.
This is a hyperbola.
Hyperbola. That's exactly what I meant. Meant terrible. Hyperbola. A parabola.
Hyperbola.
Hyperbola. So we have going to.
Is it purple or purple? There's no A in
Is it probably or probably?
Probably.
Hyperbola. Not hyperbola.
Are those the same word, just how you say it?
No.
Hyperbola.
Say. One's a word, one's not a word. They're spelled differently.
Hyperbola and hyperbola.
Wait, say it again. What's the difference?
Alright, everybody grab this one. Y equals negative 3 over x. Go.
Leave the same.
The point behind the tens is that you go far enough out that you understand where the graph is coming from. So you need to make sure you have an outlying value. You need to have a value that's close to wherever your asymptotes are. So you need to know, you need to be able to identify and graph your asymptotes.
It's just awkward to say.
It's just so,
Come on, let's go.
it's just how mod it's when you say it.
There isn't any way to say it.
I actually dogs on the stomach.
Come on, let's go. Good work.
I already know the answer. Well, I haven't grabbed it yet. It's not. It's why I
What?
Yeah, I know.
Alright, so you should have graphed this, and it should have been like this. And you need to make sure your asymptotes are on there.
Oh.
That ain't funny.
Okay? Who got this? Alright, so what we're looking for when we grade these is specific points that make sure it's accurate. If you drew this, no, you get 0. Okay? You gotta have specific points like we did here. And draw accurately, please. Yeah.
There's a different way I did I divided it into numbers and then some y, or multiplied on it, and then they all came out the same.
That's what I'm saying.
Alright.
That's what it says, figure out x times y. Alright, so here we go. Example 7, then we're done. Here's the table and an example of inverse variation. You just look at the inverse variation formula, and I'm just telling you what you're supposed to do. Take x times y. If they are all the same, then it's inverse variation.
So you take 2 x's times 2 y's and see if they equal.
Does that say 2 x's and 2 y's?
Just
It
multiply
says
them
take an
together.
x times the y.
Well, wouldn't you have to do it twice to see if you get the same number?
No, you gotta do it 1, 2, 3, 4, 5, 6 times.
And see if you get the same number on all
Next,
of them?
negative 12 times 2.
Negative 24.
Negative 10 times
Negative
2.4.
24.
You gotta check all of them, guys.
Negative 24.
Negative 24.
Oh, yeah, they do. Negative 24. Negative 24. Negative 24.
Negative 24. I am so stupid.
Y, E, yeah.
All right,
Yes.
your assignment. Page 769, 4 to 46 evens. Mixed review evens. Go.